Welcome to Plutus Project-Based Learning 2023 from Gimbal Labs. Thank you for watching this video. This is the first lesson in Module 203, 3 Ways to Mint an NFT. And in order to get started, the first thing we'll have to do is look at how to add metadata to a Cardano transaction. As you'll see, we'll be building upon some prior knowledge. If you already know how to build a simple transaction using Cardano CLI, you'll see that adding metadata is just one additional step. You'll also have a chance to practice using some bash scripts to build reusable transactions. Before we go any further, let's think about what we already know about transactions. First of all, you should be familiar with the concept that every Cardano transaction takes a set of one or more UTXOs as input and creates a new set of one or more UTXOs as output. If we're being a little bit more specific, we can talk about what is represented in each of these UTXOs. For example, every UTXO holds some value, at least a minimum amount of Lovelace, and potentially some additional tokens, and a UTXO might also include some datum. Datum is information that can be stored in a UTXO and read by smart contracts that are validating transactions. But datum isn't the only place that information can be stored on the blockchain. Every transaction includes a record of certain information. For example, the hash of the transaction, what block it was included in, the fee for that transaction, whether or not new tokens were minted or burned, and something called metadata. This is not an exhaustive list. Here's a screenshot from the Cardano GraphQL documentation, and you can see there's a whole bunch of different information we can query about a transaction. Look, for example, its inputs and its outputs. That's pretty important. When you start to build applications and all sorts of different smart contract logic, this is the sort of information that can really come in handy. For this lesson, I just want to focus on the metadata part. Metadata looks like this. It's an object, and if you're familiar with JSON, this should look familiar, that has a key and a value. In Cardano transaction metadata, the key must be an integer wrapped in quotation marks. So for example, we could have the key 2023 in quotation marks, and then a string could be the value of this metadata. Or I could use a different number, and the value could be a simple integer, in this case without quotation marks. In total, there are 5 different things a value can be. A string or an integer, as you just saw. A byte string, which can really come in handy, but we're not going to cover right now. A list of any of these other items, or a custom object consisting of some combination of these kinds of values, and this object does follow standard JSON notation. In the next lesson, you'll see how to write metadata that specifically applies the NFT media standard on Cardano. But for now, we're going to take an initial look at how to add simple metadata to a transaction, and then you'll see that you can view your metadata on the bottom of this lesson page using a GraphQL query. Let's get started. In my code editor, I've opened the PPBL 2023 Plutus template. I'll always make sure to run git pull to make sure I have the latest changes, and you'll know you're up to date with this video if you can find the script called sendtx with simple metadata. Let's open it up. This script will guide you through the process of building, signing, and submitting a transaction that includes some simple metadata. And if you've looked at the token minting scripts provided in Module 202, this should look pretty familiar. I'll leave it to you to explore most of this file, but what I'd like to look at together is this new line right here that says metadata-json-file and then provides the path to some JSON file. Before we can build this transaction, we'll have to make sure this file exists. Now, you could change the path if you'd like to, but I'm going to use the path that's included here. So, in the current directory, bash scripts, I can create a new folder, and I'll call it metadata. Then, inside of that directory, I'll make a new file called message.json. In the documentation below this video, you can see what the contents of message.json should look like. We have opening and closing curly brackets, a key, in this case 2023, and a value, in this case a simple string. I'll copy it and paste it here. And you can customize this message to whatever you'd like. For this one, I'll say live from lesson 203.1 video with an exclamation point for good measure. Whatever message you choose to write, you'll be limited to 56 characters in length. If you try to include a message longer than that, you'll get an error when you try to build this transaction. Of course, there are ways to write longer strings, and we'll cover that in the next lesson. With your message.json file successfully prepared, you should be able to simply use the provided script to complete your transaction. I'll navigate to the bash scripts folder, and then I'll try to run this script. And you can see here I get a usage message that says I need to include the path to a wallet directory. The reason I can see this message is that it's part of the shell script. And yes, we do need the path to a wallet to be provided as the first and only command line argument. Let's try it again. This time I'll provide the path to my PPBL 2023 example wallet, the one I can see right here. I've already created my message.json file as described earlier in this video, so I should be good to go. And here you can see the script found my message.json file with these contents. And you can also see that my wallet is successfully loaded. We will send a transaction back to my address. Great. All I have to do now is choose a UTXO that will cover the transaction fees. This one has 7.3 ADA in it, number 7. That should be good enough. You can see we're building a transaction. We can see that it was successful because there's the estimated transaction fee. The transaction is signed and submitted, and we get a success message right here. Now all I have to do is wait for this transaction to be confirmed on chain, and I should be able to view this metadata. After I wait a few minutes, I can actually query this address again to confirm that my transaction went through. When I built the transaction, I had 8 UTXOs at this address, and remember, I just tried to spend this one, the one that starts B3CE. I'll copy this address, and then I can use the provided getAddressUTXO script with that address as the argument to see the new UTXOs in this wallet. Now I still have 8 UTXOs, but the one that has around 7 ADA in it is different. Look. It used to have about 7.3 ADA and the transaction hash B3CE7, etc. Now it has about 7.1 ADA and a new transaction hash. But where's the metadata? One way to see it is I can copy this transaction hash and head over to Cardano Scan preprod, where I can search for this transaction. When I do, I can see that it has some metadata, and sure enough, here's the metadata I included: key and value. At the bottom of the page below this video, you'll also see a representation of this metadata directly in the PPBL 2023 course. Go take a look, and you can investigate how it works. Finally, you might also choose to explore how transaction metadata works with Mesh or with GameChanger. Both provide tools for putting transaction metadata on chain. Here's what it looks like in Mesh. In GameChanger, you can navigate to the playground and choose the Hello World metadata demo from the demos menu. Either way, I'm eager to hear about what you discover in your explorations of Mesh, GameChanger, and other tools along the way. For now, we have enough background knowledge to get started minting real Cardano NFTs. That's what we'll do in the next lesson. See you there.